The first topic in lesson 6 is called vertical scaling. So basically scaling up or scaling down our Azure SQL databases, adding more resources in or taking resources away. So there are two types of vertical scaling. We can scale up or scale down the service tiers, and we can do vertical partitioning too. Now, scaling up a service tier refers to switching to a higher service tier. So for example, you switch from a basic to a standard, say S0, or switching from a standard S0 to a standard S1 service tier. Scaling up a service tier allows you to maintain or improve database performance, maybe under a heavy workload or during peak time. But as well as scaling up, you can scale down. And scaling down a service tier refers to switching to a lower service tier. So, for example, switching from, say, a standard S1 to standard 0, or switching from standard to basic. Scaling down the service tier allows you to save costs. So when you're not using those resources, you can scale down what is available to your database, thus reducing the cost of your Azure SQL database. So for example, out of hours, you might want to scale down your service tier to save some money. We can change the service tier on the fly with zero downtime. When a service tier change request is sent to the Azure SQL database, it first creates a copy of the database in the requested service tier and switches the database in the new service tier once that copy is ready and transactionally consistent. You are charged for the new service tier once the service tier is changed and not from the time the request is received. Now, Azure SQL Database service tiers can be changed from the Azure portal using a T-SQL script, using PowerShell, or by putting the database into something called an elastic pool. Now, with the exception of the Azure portal, these methods allow you to automatically save or automatically change the service tiers. Now, I mentioned elastic pool there. An elastic pool is a group or a pool of more than one Azure SQL database with various usage workloads, and we'll talk more about elastic pools later on in lesson 7. One of the most common vertical scaling use cases is automatically scaling up or down a service tier based on DTU or database throughput usage. For example, you can put a script in place that can automatically scale to a higher database service tier if the DTU usage increases past a given threshold. So you'd switch to, say, standard F0 if your DTU usage is greater than 70%, and scale to a lower service tier if the DTU usage is lower than a specified threshold. So you could switch back to basic if it's less than 30%. Another use case is to schedule the scale up and scale down based on peak and off-peak business hours. For example, if a business expects higher traffic between 1 p.m. and 3 p.m, it can scale down to the premium service tier. If a business expects higher traffic between 1 p.m. and 3 p.m, it can scale up to the premium service tier, and it can scale down to the standard tier for the rest of the day. Okay, and we will look at this in the next. We're in a situation where we're facing higher traffic between 1 and 3 p.m. on the ToyStore database. Now, in order to overcome any potential performance issues this is causing us, we're going to use T-SQL to change the service tier. Now, the code here can be found in your code folder, lesson 6, and the SQL script is called change db service tier -T-SQL. So first of all, I'm going to open up Management Studio on the local machine, and I'm going to connect to my ToyStore database, which you can see. Okay, and then when I'm connected, I'm just going to run a select all from the sys.database_service_objectives DMV. This will give me the current database service tier for my ToyStore database. So if I execute that, you can see in the results there, database ID 5 is basic edition, its service objective is basic, and it's not part, or it's unknown whether it's part of an elastic pool. The next thing I'm going to do, I'm going to run a select star from the sys.dm_operation_status DMV, where the resource type equals database and the major resource ID equals toy store. So I'm just going to fire that up. Click on execute, and you can see there's nothing returned. Then I'm going to switch to a new query window, and I'm going to run 4 or 3 different queries in a single batch. Now, actually I'm going to run 4. There's 4 queries in this particular script. I'm going to run the first 3. Now, query 1 runs an alter database command. Query 2 will provide us with a database addition, and then query 3 is going to add a delay of 1 minute. Okay, and if I execute queries 1, 2, and 3, after 1 minute, we'll see if the database has changed its service tier. As the delay hits 1 minute, my query will complete, and we've got 2 rows returned. Now, if I run the same select from sys database service objectives, you can see there it has changed to standard, and if I run a select against DM operation status, we can see the various alter database statements that have been completed against the database. In vertical partitioning, the data is partitioned in such a way that different sets of tables reside in different individual databases. So for example, if there are 4 different schemas in a database, say finance, HR, CRM, and inventory, then one of these is stored in one independent database, as you can see on this diagram here. The vertical partitioning requires cross-database queries in order to generate reports, which require data from different tables in different databases. Azure SQL database currently doesn't support 3 or 4-part object names, such as database name, schema name, and table name. Therefore, cross-database queries are made using something called elastic query.